Factor and solve polynomial equations. A factorable polynomial with integer coefficients is factored completely if it is written as a product, so multiplication, of unfactorable polynomials with integer coefficients. So let's try the first example. We're going to factor that trinomial and name each property. First, I want to draw your attention to this factoring flowchart model. There are many out there. I wish I could give credit to whoever made this, but it's very straightforward and easy to follow. And that's the reason I like it. It walks you through. So, the first thing you do is you factor out the GCF, and then you look at the polynomial type, and that puts you in different directions. So is it a binomial, trinomial, or 4 terms? And it covers most of what you need to know. So keep this in mind as we're, look back and forth as we're working on this. You have this in your other packet. All right, so let's move forward. All right, first thing we have what's given. And now we need to factor out the greatest common factor. So look at the coefficients. What is the largest number we could divide from all the coefficients? So we have -4, we have -8, we have +60. And that would be 4. And then they all have at least one x in common. So for the greatest common factor, I have 4x, but I'm going to make it negative because I want the leading coefficient of what's left to be positive. All right, and just remember, at any point, you can check to see if you're doing the correct steps by distributing. Distribute -4x to everything, and you should have what you started out with. So self-check as you're doing this. All right, moving on, we're going to factor the trinomial. So here, to get x squared, that has to be x times x. The last term is negative, so that means I have a positive and a negative. And I need two numbers to multiply to give me -15 and add up to give me 2. So that would be +5 and -3. So put it all together, and that's our answer. -4x multiplied by x minus 3 multiplied by x plus 5. And just highlight that. All right, we could check this by changing the answer to standard form. So you could do this however you want. My recommendation is to multiply these terms, and you're going to notice it's the same steps we just did but backwards. And then just remember the associative property of multiplication, that if you were to multiply 2 times 5 times 7, you could say, hey, I'm going to multiply 2 times 5, which is 10, and then when you multiply by the 7, it gives you 70. Or somebody else might say, I prefer to multiply 5 times 7 first, and then multiply that 35 by 2. Okay, no matter what, you get the same answer. So you could multiply with my recommendation there, or maybe you want to try something different and say, I'm going to multiply these two terms first. And then whatever you get here, then you multiply by x plus 5. All right, so just make sure you check. All right, so now how does that look like with our factoring polynomial flowchart? Well, here's what we started with. We first factored out the GCF, so that was over here. And then we moved over to polynomial type, and our polynomial, this one here, was a trinomial. So that moves us down here. And once we're at a trinomial, we just need to know what is the leading coefficient. In this case, it was 1. So that took us in that step, and then here's how we could do that. And that gave us our final answer. All right, now let's factor something different. we have 4 terms this time. Y cubed plus 2y squared minus 1y minus 2, and we have to name each of the properties. All right, so this is what's given. And then next we need to group the terms. I want you to avoid doing the following. I see a lot of people do that, and you're really changing the problem to a multiplication problem if you do that. So if you want, well, you should put a plus in between there. I'll make it a little clearer in the next step. So this is what it should look like. So we should have that plus there. And now it's still the same problem we had before. All right, so moving on. We need to factor out the GCF from each binomial. So if you look at the first binomial, y to the third power plus 2y squared, you could factor out a y squared from there. What's remaining? Y plus 2. And you could check this by distributing. All right, in the next one, not much really I could do, but probably get rid of a negative 1. So that leaves me with y plus 2. And I made a cleaner version of this. All right, there it is typed out. And the key to notice is that the binomial remaining is still the same. All right, next we do the distributive property, but this time in reverse, not the way you're used to seeing it, which leads us to this. And always check when you get here, is there anything else I could do? Can I factor more? And the answer is yes. Look at the y squared minus 1. That's a special pattern called a difference of two squares pattern, and we can factor that to y minus 1, y plus 1. And that's our final answer. And like always and before, I recommend you check this. And for this one, you're called. You want to multiply the first two binomials? I think maybe go with this. Multiply those first. And then whatever you get, then you bring down the y minus 1. But it's your call. Remember, we have the associative property of multiplication. All right, next we are going to solve n to the 5th power minus 9n cubed equals 0. And again, name the properties. So there it is rewritten. That's the given. And then notice that the degree is 5. So expect up to 5 unique solutions. This is something we are going to cover later in the fundamental theorem of algebra. And of course, it makes sense we do the fundamental theorem halfway into the school year. All right, but moving on. Something not to do. Don't divide by variables. I see too often the following. Somebody says, I'm going to divide everything by n cubed. And then they have n squared minus 9. And they put equals 0 somehow. I mean, mainly it's wrong, but also you're going to get rid of solutions by doing that. So I want to stress not to do that. Okay, do not. See if a red highlighter works. Do not, or that. Do not do that. Okay, don't. All right, let's move in the proper way. The proper way is to factor out the GCF, which is n cubed, and this is what we get. And you could factor more, but you could also go with the zero product property from here. So I am going to, I like to write a line down the middle, like that. And then I set each of the factors equal to 0. All right, n cubed equals 0. I could solve that by taking the cube root of each side. And we get that n equals 0. And actually here you can have n equals 0, n equals 0, n equals 0. It's something called a repeated solution. Again, we'll find more about that in the fundamental theorem of algebra. All right, the other one, n squared minus 9, we're going to add 9 to each side. So n squared equals 9. Take the square root of each side. And don't forget plus or minus. So it's a plus or minus 3. Put that all together. And these are our answers. 0 and plus or minus 3. You don't have to repeat the zeros. All right, so we have 3 unique solutions. And to check this, we could substitute each solution into the original equation. So 0 is very straightforward. If you substitute 0, you get 0 minus 0 equals 0, so it works out. And then you should do 3 and negative 3 on your own. But if you could see it here, if let's say you substitute positive 3, essentially what we have is 3 to the 5th power, and this could be 3 squared. So it's 3 to the 5th power minus 3 to the 5th power equals 0. So no calculator necessary, and then you should check negative 3. And that should confirm that our answer is correct.